Hello, Adnan. How are you?
I'm fine, thank you. How are you?
I'm good. How is your holiday going, Adnan?
Good.
Adnan, why you never turn on your camera? Huh? Is there any reason?
What?
Why you never turn on your camera?
Mm,
I just wonder, okay? I'm not asking you to do that, but I just wonder why. Are you too busy or
no, I just left.
hmm? Do you go to the same school with Rahim?
Yes.
Okay. Are you classmates? Are you in the same class, Adnan?
No, we are not
Yes,
in
I'm
the same class.
sorry for being late.
Hmm. Okay, Rahim, we have just started. Good to see you. So where are you now? Is your background or is your room?
No, I'm not in Azerbaijan, that's why.
Really? Where are you now?
Dubai.
Really? When did you fly to Dubai?
Yeah. 2 days ago.
Hmm. So there's no quarantine there?
No, I'm in the hotel, but you have to wear masks when you go out somewhere.
Hmm. Good. For how many days did you go there?
1 week.
1 week. I see. Very good. So the whole family, right? Do you have siblings, Rahim? Brothers, sisters?
Yes, I have one sister.
Only one sister. Younger than you.
No, older.
I see. Very good. Very good. So where are we staying now? Abu, what is the name of that
No, no, not
tallest
Nevada.
tallest building? Abu?
No, it's called Burj Khalifa.
Burj
The tallest.
Khalifa. Burj Khalifa. Are you saying Burj Khalifa?
No, I'm staying in it's actually close to it.
When will you visit Burj Khalifa? Or did you already visit?
I visited 2 years ago. Maybe we'll visit this time too.
I see. Very good. Okay. You can share some pictures if you ride on a camel or if you just go to the top of Burj Khalifa. And okay, very good. Enjoy your holiday, Rahim. So then why did you join the class from Dubai?
I don't know because Sasmo is soon. That's why I didn't want to miss lessons.
What time is it now there? Is it
It's
5?
the time. No, yes, time is the same.
Oh,
There's no
time is the
time.
same. I see. Good. So time difference is 3. Okay. So Adnan is here. Rahim, you are here. Let's continue. As you know, we were solving questions from this. And now we are going to finish quickly. And after that, we will move to S1 paper 2015. And let's see. Okay. We have only 4 weeks left. And let's try to finish as many papers as we can. I think we did questions until 20 and we stopped here. Okay, that is the last question we did, I think. So we stop here. And let's just do, and all right. So the diagram shows, Rahim, can you read this and we can just discuss it? Do you remember, did we solve similar question before?
Yes,
Did you
yes, we
ever
did.
see this figure before?
This figure, no. Exact
No?
figure, no.
Okay, then because the same question but asked in different ways, they asked it was asked to grade 4, grade 5, grade 6, grade 7, grade 8 in some different ways. Okay, Rahim, read the question.
The diagram shows a rectangle being divided into 3 smaller rectangles and a square. If the perimeter of the unshaded rectangle is 48 centimeters and the area of the square is 36 centimeters squared, find the total area of the shaded rectangles.
Okay. Adnan, do you think you can solve this problem?
Yes, I think.
I think you can, right? So let's do this together. Okay. And after that, it's a kind of warm up. And after that, you will try other questions. Again, this kind of geometry questions, okay, the best way is you need to label their corresponding sides or related sides or given sides. Here it says that the diagram shows a rectangle being divided into 3 smaller rectangles and a square. Let's see here, the bottom part, right? This one is a square. All sides are equal. If the perimeter of the unshaded rectangle is 48, so we are talking about this unshaded rectangle. Let's say its length is A and its width is B. So it's saying
Hello.
that the perimeter of this rectangle, I will give 2
Sorry,
times
Mr.
A
I
plus,
forgot that we had a lesson.
what did you
Mister, I
say?
forgot. That's we had a lesson. That's why.
Okay. So when did you remember that you forgot you have class today?
They wrote to my parents that I'm not in the class, so they told me and I came.
Okay. Look, Wagif, even Rahim is in Dubai and he's joining the class from Dubai, you know? He might not actually join the club because why? Just cross your legs and lie down and watch something, right? Or
Mister, I
go
haven't
out and
slept
eat.
for 24 hours, Mister. That's why I
What?
forgot everything. I haven't
What?
slept for 24 hours, a whole day straight. So that's why I
Why
forgot
didn't you sleep?
everything.
You practice all Sasmo questions?
No, no, Mister. I practice, but like,
Why didn't you sleep? Why? What is the reason?
Mister, because I was not in Baku, that's why I went away, and that's why I needed to come back, and there was like a whole day I needed to go.
Okay, good. So are you okay now, Wagif?
Yes, I guess, Mister.
Okay, no problem, Wagif. After 5 minutes, you will fall asleep. I know that. So now 5 minutes you appear on the screen. After that, you turn off your camera and just keep talking for another 5 minutes. After that, completely quiet and sleep. Okay. Now this time is too fast, Wagif. Anyway, so here the perimeter is given. We know the perimeter is 2 times length times width plus width. That's equal to 48. Now immediately from here we can just find this relationship, how A and B related to each other. That means that the sum is equal to 24. And we are going to use this information here. What is the question here? The area of the square is 36. That means that one side is 6. Now from here, the question is, what is the area of the shaded region? Let's say the first part is A1. The second shaded part is A2. And opposite sides are equal, so this should be A. Opposite sides are equal, so this should be 6. And here it is 6, and this one is B. Now from here, the shaded region is equal to A1 plus A2, which is equal to, what is A1? It's just a rectangle, right? Length times width. So that's equal to 6A. And the second one is B times 6. That's equal to 6B. Now, as you see here, 6 is a common factor. And here we have A plus B. And we know the value of A plus B. That's equal to 24, which is equal to 144 cm squared. Sometimes students, when they just write the expression and they get stuck and they cannot continue. But sometimes we do not have to know the individual value of these unknowns. Maybe sometimes just knowing the sum, that would be enough to solve the problem. And next time I will ask a similar question. I hope at that time you will be able to solve this question.
I have a
Okay,
question.
Rahim, is it clear?
Yes, but most of the time in this kind of questions, is width double length? Is length double the width of a rectangle?
What? Double?
In these kind of questions, most of the time, is the rectangle like length is double the width? So width 2 is length.
No.
So
Why are saying that we have no such thing here?
no, for example, if the sum is 24, A plus B is 24.
Okay.
Oh, wait, no. Nothing, forget.
Because you don't have to know this thing. There's nothing. Just we know there's sum. From the perimeter, from that information, I'm using that. The sum of A and B is 24. Okay, let's move to the next question. Adnan, can you read the question?
Yes. What are the dimensions of a cuboid that is made from 2015 1 centimeter cubes if all the sides of the cuboid are longer than 1 centimeter?
What are the dimensions of a cuboid that is made from 2015 1 centimeter cubes? Okay, now here, of course, you should understand that we are not allowed to divide one small cube into smaller pieces. We're just using the whole cubes. And we have 2015 small cubes, right? The small cubes. How many? We have 2015. So, and now we are going to build, what is it? A big cuboid using these cubes. That's our cuboid. Cuboid means just a box, right? Or you can just think of a matchbox or any box that we use to put biscuits or something. So that is length, and this one is width, and this one is height. And since we are using 2015, 1 centimeter cube, this one is 1 centimeter, 1 centimeter, 1 centimeter. What is the volume of this one? It's 111. That's equal to 1 cm cube, right? So now then, what is the volume of the big cuboid? The volume of the big cuboid will be length times width times height, right? And we have used 2015 such small volumes, so it will be equal to 2015. And it says that each side is greater than 1. And since we are using these cubes, right, for each side of the cube, actually the length and width and height of this cuboid must be whole numbers. So which means that now just I need to factorize this 2015. And we know that 2015, it is divisible by 5. Is it divisible by 3? No. It is divisible by 5. If you divide by 5, that's equal to 403. If 403, is it divisible by 7? No. 11? No. 13? Yes. So if you divide it by 13, 40 is divided by 13, it is 3. 13 is divided by 3, it is 31. So 31 is divided by 31, that's equal to 1. So now that means that this 2015, we can write it as 5 times 13 times 31, right? So that's only the possible way. So here, the length of the cuboid is 31 centimeters, and width it is 13 centimeters, and height is equal to 5 centimeters. These are the dimensions of the cuboid.
But how do you know which one is length, which one is width, which one is height?
Usually length is the longest side, right? With the
Okay.
second one
And
in height. But here,
height
Rahim,
is
it
the
doesn't
longest.
matter how you just write this, okay? Even without writing this, the dimension, you can
Okay.
just write your answer. Dimensions, okay, they are 31
They will count it as
centimeters,
correct?
13 centimeters, and 5 centimeters.
Okay.
You don't have to mention length width, but usually when you just say cuboid, length is the longest side, and width, and because when it's just standing on the ground, okay, the longest side we call this length, the second longest side we call this width, and third longest side we call this height. It depends on how you actually put this on the ground. Okay, that's it. Now next question I am going to ask you, very easy question. Okay, Rahim, first read it and I will give you just 1.5 minutes for this question.
A number gives a remainder of 3 when divided by 10. Another number gives a remainder of 4 when divided by 10. The sum of these two numbers is multiplied by 6 to give the third number. What is the remainder when the third number is divided by 10? Okay.
Rahim, do you have any idea? What do you think? How can we solve this problem? Just tell me the idea. So we are talking about
Okay.
any number, right, Rahim? Just tell me, a number gives a remainder of 3 when divided by 10. What number is it?
Any.
You can take any
So
number.
yes, any number just with the ending of 3.
It is 13, right?
Yes, 13, 23, 33, 43.
Yeah, let's just choose one of them, the smallest one, the
Okay,
easiest one.
Okay, 13.
Another number gives a remainder of 4 when divided by 10. So another number is 14. So the sum of these two numbers is multiplied by 6. So the sum of these numbers, a plus b, that's equal to 27.
Yes.
And multiplied by 6, 6 times a plus
7.
b, that is 6 times 27. which is equal to 120, 42, 162. The question is, what is the remainder when the third number is divided by 10? So if you divide this by 10, that's equal to 16 times 10 plus 2. So if you divide it by 10, it is,
2.
what is it? 2.
2. Okay.
And one simple way, in general way we can solve this, but sometimes we don't have to think in general way, because in this way, actually, we can get the answer much faster. Read the question, Wagif.
Find the 215th term of the following sequence: 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5, 5, 5, 5. Right, mister?
Yes. Here we are just writing a kind of number sequence. What is the rule? Here, write 1 1 time, 2 2 times,
N plus
3
1.
3 times, 4 4 times, 5 5 times. If you just continue writing in this way, in this manner, okay, the question is, what will be the 2015th term of this sequence? Guys, I will give you 2 minutes. Give a try first, okay? That is not difficult question. I can just give you one hint. You are going to use this idea. We know that the sum of, let me just write here, hint,
N
the
natural.
sum of the first n natural numbers, let's say this n, that's equal to, what is it? N times n
2000.
plus 1 over 2. Hint. Adnan, are you trying to solve this?
Yes.
Okay, let's see, Adnan. If you can solve this question, I will give you gold medal. Adnan, any answer?
No.
Adnan, did you understand the question?
Yes.
Now, if I ask you, Adnan, this question, what will be the 10th term in the sequence? What will be your answer?
Is it 2015? Ah, no, no, no.
No, it's a lot. Rahim, I will just make a guess, okay?
I got 8056.
8,000?
Yes.
It is too much, Rahim. It is too much. Here, if you just keep writing, suppose that we are just 4 times 5, 5 times 6, 6 times, after some number, if I just write n, for example, and also if it is n, we need to write n, how many times? N times, right? Because 1 is written 1 time, 2 is written twice, 3 times, 4 times. So if you just actually keep writing this, when we just come to number n, it will be written n times. So now, Rahim, if I ask a question, just tell me how many numbers do we have here? Or how many terms do we have here? To find this, I need to find their sum, right? And one time, one time, two times, three times. How many numbers if I just write until n? At the time, one time, two times, three times, dot, n times. So the sum of these natural numbers is equal to n times n plus 1 over 2. Okay, so now it says that 2015th term. Okay, and suppose that this n, okay, this one is maybe this one or maybe the previous one, I don't know. That is 2015th term. So at the time, this should be equal to this n, right? 2015th term. So we have this many numbers, right? 2015th term means until this number, suppose that this number, for example, 2015th term, that means that until here, we have written 2015 terms, right? Because 2015th term means before that, we actually have written 2015 term. That means that the sum of these numbers should be equal to 2015. But now if you just find n here, n times n plus 1 is equal to 2 times 2015, which is equal to 4030. Okay, so the question is, can I write to 4030 as a product of two consecutive numbers? So to do this one, let's say, for example, you can just check, for example, let's say which one is close to 4030, like 62, for example, 63. What is 62 times 63? 62 times 63 is equal to 3906. And how about 63 times 64? 63 times 64, that's equal to 4032. But here we have 4030, right? So that means that if n is equal to 64, let me just write here one more time. Here we have 1, 2, 2, 3, 3, 3, and here we have 63, 63, and dot, the last one is 63. That means if I just write all of them, how many numbers do we have here?
6.
Huh? 2016, right? Because this one is, as you see here, 63 times 63 plus 1 over 2, that's equal to 2016. Right? The sum of the first 63 numbers, if you just stop until 63. So that means that 63, this one is 2016's term. The previous one will be also 63. So 2015's term in the sequence will be, what is it? 63.
Okay.
Adnan, any questions?
But why did you multiply 2015 by 2?
No, because here we have 2, right? I just took this to the right-hand side.
Ah, okay.
But Rahim, I suggest you to solve this one more time on your own without looking at the solution. And at that time, you can understand much better. Because these kind of questions are usually asked a lot in Math Olympiads. Idea is simple, but if you cannot see this, you know the pattern, you cannot solve this problem. And this year, Rahim, maybe they will ask you, for example, the same thing. How about if they ask you 2021? At the time, maybe this 2021, what will be the answer?
2028.
It is just 64, Rahim. Because here, until when you just write 63, we have written 2016 numbers, right? 2017, it will be 64. Now I need to write 64 times, right?
Ah, yes, okay.
So
yes,
here, 1, 2, 3, 4, 5, so it will be 64.
Ah, okay.
Okay. Rahim, read the question.
We did this question. We did
really?
This question.
What was the answer?
I don't remember the answer.
Here, the idea is, let's do this again. Just read it first and let's do this one more time.
In a school hall, 8 out of 13 of the chairs are arranged in rows of 7, and 5 out of 13 of the chairs are arranged in rows of 11. The rest of the chairs are stacked up. If there are less than 2,000 chairs in the hall, find the total number of chairs in the hall.
Okay.
And we did a different question.
We actually Wagif Adnan Rahim. When we actually talking about this question, also we need to understand actually it's about what, right? If you're talking about, for example, people, right? Let's say the unknown must be a whole number. If you're talking about also chairs, that means that immediately that n, I mean the number of chairs, it must be a whole number. Now here in the first part, suppose that in the whole we have n chairs altogether. So now it says that 7/13 of the chairs are arranged in rows of 7. What does it mean? 8/13 of chairs. That is, and it is in rows of 7. That means that 8/13 of the chairs are divisible by 7, right? So I can just write it as 7 times 8. And how many rows do we have? Maybe 8 rows we have. And it says that 5/13 of the chairs are arranged in rows of 11. That means also 5/13 of the chairs, they are divisible by 11. That's 11 times some natural number. This A, capital B, they are natural numbers or simply whole numbers. Now from here, Rahim, what should we understand? As you see here, this 13 and here we have n, right? So that means that this n, right, must be divisible by 13. Otherwise, we cannot have whole number. On the right-hand side, we have whole number. Also, left-hand side must be whole number.
So
that means
either
that
13 or 1.
So number one is this n should be 13 times something, right? So now if it is divisible by 13, suppose that n is equal to 13 times, for example, let's say m, okay? So now if you substitute here, I have 8/13 times what is n is equal to 13 times m. That's equal to 13, 13 cancels each other. 8m is equal to, on the right hand side, we have 7a. Or 8/13 times 13m. Sorry, the second one is 5, right? The second one is 5. We have 5, 13m. 13, 13 cancels each other. 5 times m equals, what is it? 11 times b. Okay. Now from here, what do you understand again? This m, right? M, because 8 and 7, they are relatively prime numbers. So that means that this m must be multiple of 7. At the same time, this m must be multiple of 11 from here. Otherwise, I cannot write this m or 5 times m as 11 times something, right? So from here, what do we understand that from here? Then n must be equal to 13 times 7 times 11 times some number. What number is it? I don't know. Let's say some number is, let's say this c. But if you multiply these numbers, 13 times 7 times 11, that's equal to 1001. If c is 1, it's okay. If c is equal to 2, for example, it will be greater than 2000. But here in the question, it says we have less than 2000 chairs. So which means that here c must be equal to only 1. So that one is n is equal to 1001. And how many chairs are stacked up? 0 chairs. So the number of chairs must be 1001, which is divisible by 13, which is divisible by 7, which is divisible by 11. We don't have any other choice. Any questions, Rahim?
No.
Good. Let's do the last question then. Find the remainder when 3 to the power of 2015 is divided by 4. How do you solve this question? Okay. Like once again, let me just write it one simple equation. Actually, we just use that thing for division algorithm. Okay. For example, let's say if you're given any number, that number is, let's say it is n. Okay. And suppose that when I just divide this by a, the quotient is q, the remainder is r. Okay. So that means that if you divide this n, for example, n to the power of k, for example, so that's equal to a times q plus r to the power of k. Just raising to the power of k both sides. Again, actually, if you just divide the right-hand side by a, okay, so the remainder will be, I can just write it as a, if you divide by a, sum, actually, the quotient we will have here, and the remainder will be r to the power of k. Okay. Uh, Maybe it's when we just write a lot of letters, it may be a little bit confusing for you because if you have never seen this. But what I'm talking about here is very, very simple logic, but very fundamental idea in division algorithm. What I'm saying here is, for example, here we have 3 to the power of 2015, right? I can just write it as 3 to the power of 2014 times 3 to the power of 1, because just what a simple thing is a to the power of m times a to the power of n, that's equal to a to the power of m plus n, right? For example, 2 squared times 2 cubed, that's equal to 2 to the power of 2 plus 3, that's equal to 5. 2 squared, it is 4. 2 cubed, it is 8. 4 times 8, it is 32. And that means that 2 to the power of 5, that means that if you multiply 2 by itself 5 times, we will get 32. So now I will continue. From here, again, 2014, I can write it as 3 to the power of 2. And here we have 2014, that's equal to 1007. And here we have 3 to the power of 1, just 3. So as you see here, 2 times 1007, that's equal to 2014. I'm just using this idea again. Here we have 2 squared and 3. What is it? It is just 2 to the power of 2 times 3. That's equal to 2 to the power of 6. So now if I just continue here, 2 squared, 3 squared is equal to 9. So 9, because we are looking for the remainder when we divide it by 4. So 9, I can write it as 4 times 2 plus 1 to the power of 1007. Now here we have 3. So now if I just use this idea here, if I divide, for example, 9 by 4, the remainder is 1. Now, if you divide 9 to the power of 1007 by 4, the remainder will be, what is it? The remainder will be 1 to the power of 1007. So now I can just write it as 4 times some number, and the remainder is 1 here. And here we have a 3. And now if you remove the brackets, 3 times 4, I have here 4 times 3a, and 3 times 1 is equal to 3. So we have 4 times something here and plus something. That means that on the left-hand side, I have 3 to the power of 2015. If you divide it by 4, the remainder will be 3. So the remainder is 3. Yes, Rahim, Adnan, Wagif, any questions? I can give you another example to understand this, Rahim. For example, let's say 5. Okay, in the first one, it is 3 to the power of 2015 How about 5 to the power of 2015 is divided by 5? Is divisible by what? Again, 5, right? I can just 5 to the power of 2015. I can write it as 5 plus 1 to the power of 2015. So that means that if you divide actually this number by 5 times 1 here, the remainder will be 1 to the power of 2015. So here we have, that means that here I have 5 times some natural number. It's a very big number actually. Here we have 1 to the power of 2015, which is equal to 5 times a plus 1. On the left hand side, I have 5 to the power of 2015. On the right hand side, I have 5 times a plus 1. What does it mean? It means that if you divide this number by 5, the remainder will be 1. And now, if you wonder again, Rahim, why actually you are writing this, the first time if you see this, it may be a bit weird, but actually it's very, very simple logic. What I'm doing here is, for example, a plus b squared. Do you know how to expand this, Rahim? Did you ever do this? What is a plus b squared?
A plus B squared.
Actually, if you don't know, we can just do this. A plus b squared means a plus b is multiplied by a plus b. So if you just multiply this, a times a squared, a times b, b times a, b. So their sum is 2ab plus b times b, it is b squared. Okay. So I'm saying that here, that actually just if you just keep the last term and all the other terms, they have always a common factor of a. So I can just write it as a times a plus 2b. Now still I have here b squared. And here a and b, they are whole numbers. And the sum of the whole number is a whole number. I'm just labeling this by something. Okay. So let's say it's equal to some number because I don't need it. What is that? Okay. And what I need here is I need this b squared, b squared. What should we understand from here? That means that if you divide this a plus b squared by a, the remainder will be b squared. Like for example, again, 101 or 1001, okay? If we divide by, for example, 5, what is the remainder? So that means that I can write it as 5 times 200 plus 1. And this 200, let's say some number. I'm not interested in the value of this number. Okay, what I need here is this one because I'm dividing this number by what? And what is the remainder? These are interesting for me. So I can just write it as 5 times n plus 1, which means that if you divide 1001 by 5, the remainder is 1. So
Yes, I
now
understood now.
if you are, for example, 1001, let's say 1001, the last example, to the power of 2021. When we divide by, for example, 4, what is the remainder? So I can just write it as 1000 plus 1 to the power of 2021. And this 1000, I can write it as 4 times 250 plus 1 to the power of 2021. So which is actually, I can just write it as 4 times some number a plus 1 to the power of 2021. A 1 to the power of 2021 is just 1. So I can just write this 4 times a plus 1. That means that if you divide this number by 4, the remainder is 1. All right, that's it. Let's move on. I'm going to finish this and let's start a new paper. We have like 15 minutes. We can solve at least 8 questions, I hope. Okay. Now we will practice 2016 papers. We will start with P6 today, and hopefully this week, if we can finish this, next week we will practice 2016 S1, and after next week, maybe 2017. And let's see, today is 24 March, and grade 7A. Okay. All right, read the question. Let's try to do 8 questions, okay? But we should do quickly because the first questions are easy. Read the question.
Suppose it is now the month of December. What month will it be 10 calendar months from now?
100.
100 calendar months from now.
What is it?
How do I know?
How do you know? Because every 12 months, we will have the same month, right? So we should divide 100 by 12. That's equal to 96. And plus 4, the remainder is 4. Because now if it is December, so 100, we can write it as 8, or not 8, 12 times 8 plus 4. That means that from now on, right, 96 month, right, 96 month, it will be again December. So the next 4 months, that means which one is it? It is January, March, April, May. So the answer is December, January, March.
February. No, you forgot February.
January, February, March, and
It's-
April. 4th month is April, right? So the answer is April.
Wait, so what month will be? So you took 100 divided by 12?
Because in 1 year we have 12 months, right?
Mm-hmm.
After every 12 months, we actually start new year.
Mm-hmm. 100 divided by 12. I did on calculator, I got 8.333 recurring.
Yeah, you should not divide like this. You should divide by 12. The remainder will be 8. It's just a simple number. Divide by 12. It is 8. 8 times 12, 96. The remainder is 4. So now I can write 100 as 12 times 8 plus 4.
Okay.
All right. Next question. Adnan, are you here?
Yes, I'm here.
Adnan, read the question.
6 machines can produce 15 items every 30 minutes. How many additional machines are needed to produce 70 items every hour?
Okay, it says how many additional machines. In Sasmo, you need to read the questions twice, okay? Just reading one time, it may not be enough. They are not asking how many machines, but they are asking how many additional machines.
It's none
So
of the
now,
above.
huh?
None of the above.
So here
Yes.
we have 6 machines, right? Can produce 15 items in 30 minutes. This one is machines, right?
Oh no, I
This
took
one is items. And this one is time, minutes. Okay. So the question is, how many additional machines are needed to produce 70 items every hour? So that means that here, every hour, right? That means that we know that 6 machines. And how about in 1 hour, they can produce how many items? 6 machines, they can produce 30 items in 1 hour. Because 30 minutes, right? 30 more minutes, they can produce 15 more, so it is 30. Okay, so now it says 70. So how can we get 70 from here? Right now, if you just fix the time, right? So if we have more machines, they can produce more items, right? Less machines, less items. So now that means if I multiply both of them by the same number, it does not change. So now to get 70 here, I should multiply this by, what is it? 70 over 30. So 70 over 30 times 6. And 70 over 30 times 30. And time is not changing here. So now actually they cancel each other. 70 is left. 6 over 30 is 1 over 5. 70 over 5, that's equal to 14. And here we have 70, and here we have 1 hour. So how many more? It says more, that is 14. Initially we had 6, so we need 8 more machines. Okay. Next question. Wagif, are you here?
Of course, mister.
Wagif, can you read the question and also do it for us?
How many of 17 whole numbers must be odd if their product is odd?
How many of 17 whole numbers must be odd if their product is odd? What do you think?
1 second, mister. I'm thinking. Is it 17?
17?
Still 17.
It is 17. Why?
Like,
Because if their product is odd, right? It says product is odd. We know that even number
product.
times odd number is always even number.
Even number.
So if their product is odd, that means that
Yeah.
all of these numbers must be odd numbers. It cannot be even. So that means that how many of 70 whole numbers must be odd if their product is odd? All of them must be odd, because even one of them is even, then their product will be even. So it is 17. Rahim, can you do this question? First read it and explain. It's a very easy question, I think. I don't know. Let's see. First read it.
In a magic show, the magician plays 4 cards on the table as shown below. Each card has a math symbol on one side and a number on the other side. After showing the cards, he flipped over some, maybe all, of the cards and rearranged them. The new arrangement of the cards is shown below. How many of these 4 cards have an even number on one side? How much time do we get?
Hmm?
How much time do we get?
I don't know. Can you do this? Let me give you 2 minutes.
Okay. Is it C? Ah no, D.
D, Y.
Because 5 is an odd number, and when division symbol was flipped, 5 was on the other side. 4 didn't get flipped. 6 was flipped for minus, 2 odd numbers, and then plus was flipped. I don't know. It's either 2 or 3.
Yeah, your answer is 3. That's correct.
Oh, okay.
Because in the magic show, the magician plays 4 cards on the table as shown below. Each card has a math symbol on one side and a number on the other side. That's plus, division, Let's say addition, division, 6 and 4. After showing the cars, he flipped over some, maybe all, of the cars and rearranged them. The new arrangement of the cars is shown below. So as you see here, 4 didn't, right? And here we have plus, division, and multiplication minus. So since actually here we have 4 cars, right? And we have math table on one side and the number on one side, that means that here we have all of these symbols are already, we know actually, we have addition, division, multiplication, minus. So 4, it is not flipped, right? And 6, so that's another even number. So this multiplication, it must be behind this multiplication, it must be 6, right? Or 6.
Or behind minus.
Behind minus. Okay, let's say this 6. Then how about the multiplication?
But we don't know any other numbers. How do you know it's even? We don't know anything else except for 6 and 4. How do you know the next number is even?
Okay. Let's say these are our cards. So 4 is not flipped. Right, here we have plus addition. Okay. So here we have plus addition. We don't have plus addition. We don't have 5. So behind this 5, it must be plus, right? Plus or minus. Behind this 4, it must be plus addition or division. Okay. So behind this minus, it must be 6. Behind this multiplication, it must be, what is it? So that means that this 4, right? Here we have multiplication, we have division, right? Behind these numbers, there must be these 2 numbers because we already have 2 numbers here, right? So these numbers behind this multiplication and minus, they cannot be 6 and 4. I mean, 5 and 4, okay, behind multiplication. So this should be 6 and this should be 4, right? So after showing the cards, he flipped over some, maybe all of the cards, and rearranged them. The new arrangement of the cards is shown below. How many of these 4 cards have even number on one side? How many? That is 4, 1, 2, and 3. Because here we have addition and the division. Here we have multiplication and the subtraction, right? So actually we know that behind this plus and division, they are not 6 and 4. But actually here we have 4, right? And this behind multiplication, it must be either this number, or behind subtraction, it must be either this number or 6 or 4. Right? Because here, from here behind the 6, maybe we have, if we have multiplication here, then here we have subtraction. If behind 6, if we have subtraction, then it must be multiplication here. In either cases, actually behind this multiplication minus, we have 4 and 6. Because in these first 2 cards, we don't have multiplication division, because one side, one phase, it has operation, another side, we have a number. Because it says that, as shown, each card has a math symbol on one side and a number on the other side. So that's why we have 2, 4, and 1, 6. So we have 3 even numbers. Anyway, I mean, we can think once again. I think it's very simple question. That's enough. Thank you very much, Rahim. Enjoy your holiday. Wagif, Adnan, take good care of yourself, guys. Okay, see you on Friday.
Bye. Have a nice day.
Bye-bye. You too, guys. Thank you.